Hello students, welcome to the class. Today in the mental ability series, we are starting with a new chapter named Cubes Test. As the name suggests, in this chapter we are going to deal with the questions related to cubes. So what exactly a cube is and how it is different from other shapes and what kind of questions we are going to deal in this chapter. I am going to explain you in detail one by one. So at first I would like to explain what exactly a cube is. Everybody is aware of a square with what? Four equal sides, right? So cube is nothing but a 3D structure of a square itself, right? In this we have a extended square to form a 3D shape, which is like this. Everybody is very well aware of dice as well. Like in your childhood you must have played this game in which you use a dice, right? So dice is basically an example of cube itself. So what are the basic parameters of cube? It has how many faces? Total of 6 faces, right? All these important things will be very helpful for you while you are answering to the questions, right? Now how many edges are there? For that you can calculate as well. I'll change color as well, right? This is 1, this is 2, 3 and 4. 4 on the top, right? Similarly, talk about others, that is 5, 6, 7 and 8. 8 at the bottom, right? And we have 4 more edges that are vertically inclined, right? This is number 9, number 10, number 11 and number 12. I hope these all are clear. Total how many? Total of 12 edges, okay? What other parameters we have here? You can see small vertices as well, right? I'll mark them with different color. You can see these dots. These are nothing but the vertices. While marking, you can calculate them as well. They are total how many number? They are 8. What? They are 8 vertices, right? All these 3 parameters, right? 6 faces along with 12 edges and 8 vertices. What they form? They form a 3D shape if all edges, what the condition is, if all edges are equal, it means it is a cube. I hope everybody is clear with the shape named cube, right? I'll explain you one more shape here itself, that is cuboid, so that you will never get confused between both of them. So what exactly a cuboid is? We know the difference between a rectangle and a cube, right? What is the difference? The length changes. So here in cuboid also, one of the dimension, either its length, either its breadth or its height, any one of them will change. They'll form a thing like this. You must have seen a brick. Normally a brick is in the shape of cuboid. So this is what? A cuboid. And when we convert this with all equal sides, we are going to get a cube. So this is a cube. I hope you are very clear with both the figures, that is a cuboid and a cube. For a cube we have a good example of dice, right? As well as for cuboid we have a good example of brick, right? So I hope till here you are clear with the dice, clear with the brick, their shapes, and what are the basic dimensions here. In a cube as well as in a cuboid, length is there, breadth is there, as well as height is there. So in case of cube, what is this? L is equals to B is equals to H, and in case of cuboid they are not equal. They can be either two of the side, like length and breadth can be equal but height is not equal. Otherwise length and breadth is not equal but it is equals to the height, right? And any possibilities can be there. Or third one is neither the length nor the breadth equals to height, or they are not equals to each other as well. I hope this part is also clear, right? This is the basic introduction of a cube, and now we are going to deal with the different questions which are related to cube itself, right? So here are some basic more instructions which is related to cube itself. right? A cube is a three-dimensional figure. Make a note of it. You can write it down in bullet points. The first point is cube is a three-dimensional figure. I hope you are clear with this. Second, having 8 corners. Corners means vertices. Total how many vertices are there? Total of 8 vertices are there, right? 6 faces or surfaces, right? Surface means any plane area, that is called a surface. So how many surfaces are there in a cube? Total of 6 surfaces, right? 12 edges. Edges stand for border lines, right? Total of 12 border lines that we have marked in the previous figure. I hope you are clear with this, right? If a cube is painted, now we are dealing with the problem statement as well. If a cube is painted on all its wall surface with any color and further divided into various smaller cubes, what exactly is they are talking about? Let's say this is the topmost portion of a cube, right? And that particular cube is divided into how many squares? Let's say 16 small squares. This is the basic division that we have, right? So, and they all are painted, let's say red. They all are painted, let's say red. Similarly, all 6 faces are painted with red color. Okay, we get the following result after that. What are the results that we are talking about? Because here are some cubes which are going to get only one color, especially those who are at the center. These, right? But those who are on this side, because we have another side here itself, so the division will be like this. So this particular face or this particular small cube will be have 2 sides painted, right? In the similar manner, all those squares, small squares, those who are present at the vertices will have 3 side painted. How many sides? 3 side painted, because every corner touches how many surfaces? 3 surfaces. It means 3 sides are painted for the small square or the small cube which is at the vertices. Which is at the edge will get 2 faces colored, and which is at the center, neither on the vertices nor on the edges, will get only one face colored. I hope you are clear with this, right? For that, I'll give you a generalized formula through which you are able to understand how many cubes or the small cubes are painted or with how many colors or from how many faces, right? Because every small cube also have all the all the features that a big cube is having, right? It just its dimension was less as compared to the bigger cube, right? So here are some diagram with the help of which you are able to understand everything now. So this dot is a corner or a vertex. What? A vertex, right? Edge, surface, or we can directly mention face, right? So total how many faces are there? 6 faces with 12 edges and with 8 vertices. Why I am repeating everything again and again? So that you are able to remember these things, you are able to retain these things while attempting different questions, right? Here is an example. Let's say the complete cube is painted with red. Let's say it is painted with red color. I hope this part is clear. Okay. If this complete cube is painted with a red color, now we need to figure out how many smaller cube are painted with 3 sides, are painted with 2 sides, or only 1 side. So for 1 side we'll write 1, for 2 side we will write 2, and for 3 sides we will write 3. So as I have already told you, the smaller squares or the smaller cubes, those who are at the vertices, will get 3 side painted, right? How many sides painted? 3 side painted. I hope this part is clear, right? You can see 2 here, 3 here, and the 4th one is here, right? Similarly, 5th one is here, 6th one is here, 7th is here, and 8th is just below it, right? Just below it somewhere will be the 8th. So how many smaller cubes will get all 3 sides painted? So for 3 sides, how many will have? 8 smaller cubes. I hope this part is also clear, right? I hope you are clear with this statement. How many smaller cube will have 3 sides painted? So for this I have write 3 sides, and how many smaller cubes? 8 smaller cubes. Now we will discuss about 2 as well as 1 here itself, right? What you can do, I'll redraw this line just to make it more clear, right? Again here, yes. Okay, now we have enough space for further tasks, right? Now number of smaller cubes that have 2 faces painted. So I have already told you those who are present at the edges will get 2 faces painted, but we will exclude all the cubes which are at the vertex now because we have already counted them. So we know at total of how many edges are there. We know 12 edges. I hope you are clear with this, right? At every edge, like in this edge we have 2 cubes, okay? In this edge also we have 2 cubes. In this edge we have 2 cubes. In this edge also we have 2 cubes. So like these 4 edges are there, we'll have 2 each. Again 2 here, 2 here, and 2 here, and 2 just opposite to it, right? It will be there, right? If we redraw these lines, right? So 2 will be here as well. So how many are there? 8 more are there. Similarly 2 at the back, 2 just at the lower part, 2 here, and 2 adjacent to it. Total of how many? 2 into 12, that is 24 what? Smaller cubes. I hope this part is also clear, right? I'll make this cube a bit clear so that it become easier for you while you are watching this video, right? Just a second. Yes. I hope this part is clear. I'll draw the hidden lines again here so that you know how many edges we are calculating and what all squares we are talking about, right? So for that, what you can do, you can just redraw the hidden lines here, right? These are the hidden lines because it is a solid cube. Now I hope this part is also clear, right? I have already talked about each and everything, but one thing is left here as well. So for that, what we will do, we know how many faces are there? 6 faces are there. At every face, how many smaller squares are there with one side painted? Total of 4. So 6 multiplied by 4 gives us 24. So 24 smaller cubes will be there with only one side painted. So we know for 2 sides, how many we have? 24 smaller cubes, right? For just a second. Yeah, we will write this thing here itself, right? Or we will read it again. What is this? Smaller cubes with 2 surfaces painted will be present on the edges of a big cube. We have already did this part. Smaller cube with one surface painted will present on the surface of big cube. So how many surfaces are there? 6. We know this. How many edges are there? 12 edges. Okay. Smaller cubes with no surface painted will be present inside the cube. Remember, the surface that you are able to see are the only place where the paint is there. But inside that as well, we have smaller cubes. And those smaller cubes are not painted with any of the color. Okay. So they will be marked as colorless, right? Now read it. If a cube is painted on all surface with a color, then divide them into smaller cubes. Now this is the instruction part. If a cube is painted with a single color, then divide it into smaller cubes of equal size. Make sure of equal size. Then after separation, the number of smaller cubes so obtained will be calculated as. Now we know that in the previous diagram, how many smaller cubes we are going to get? Total of how many? 16 cubes if we are dividing 4 on each side. I hope this part is clear. Okay. This is only one surface, right? Now, we know that the number of smaller cubes with 3 surface painted, 8, because we have 8 vertices, right? This part is clear. Okay. The number of smaller cubes with 2 surface painted, we have total of 12 edges, right? I hope this part is also clear. The number of cubes with 1 surface painted, we have 6 faces. I hope this part is also clear. So whenever it is asked how many surface are there with 3, how many cubes are there with 3 surface painted, we look for the number of vertices. If they are asking for 2 surfaces, we will look for what? Number of edges. And if they are asking for only 1 surface painted, we will look for number of face. With this, you are able to find out all the smaller cubes in number, right? The number of cubes with no surface painted, it means they are present where? Inside the surface. For which, for everything now we have formula, right? 8 will be remain fixed for the cubes, because cube will always have 8 vertices irrespective of their size, right? Now the smaller cube will depend with 2 surface painted will be depend on the number of divisions. So n will be there. So the generalized formula will be n minus 2, and n is the division. Why we are subtracting 2? Because 2 edges will be there on either of the ends, on both the ends basically. Why we are multiplying it by 12? Because we have 12 edges. Similarly, the number of cubes with 1 surface painted will be n minus 1 square. Why I am doing this? Because let's just take an example of the previous cube in which we have 4 divisions, right? So if we solve this, 4 minus 2 whole square multiplied by 6, what we are getting? 4 into 6, that is again 24. We are getting the correct answer. And why we are multiplying it by 6? Because total number of faces are 6. Similarly, for the number of cubes, those who are not painted, we know, we'll take example of previous cube itself, then it will be 4 minus 2 whole cube comes out to be 2 power 3 comes out to be 8. So 8 cubes will be there, right? 8 cubes will be there, 24 will be there, and 24 will be there, it's there also, and 8 is there also. I hope I am able to explain this part very well, because we have already discussed an example with multiple colors, so you are able to understand this well. I hope this part is clear. Now I am moving to the next part, where we know that we are using the value n. What exactly n is? Number of divisions that we have already discussed on the surface. In the previous, we have how many divisions? 4 divisions. On the cube, we have discussed in the starting, right? So how you can find the division? First, you can, okay, I'll give an example again, right? If this is a bigger cube, right? This is a bigger cube, and we made certain division on this. How many divisions are there? 4. Let's say this complete have dimension of 20 meters, and the smaller cube that we are able to form have a dimension of 5 meters. So how many will be there, right? So for that, how many divisions will be there? For that, what we will do? We will take the length of bigger cube, that is 20, will divide it by the length of smaller cube, that is 5. What we will get? 4. So 4 division will be there. This formula can be used in this particular manner. I hope you are clear with this, right? I hope now I have explained you everything related to a cube, right? Now we'll move with the type 1 kind of problem. In this chapter, total of 4 types will be discussed with some certain questions as well as examples. I'll tell you how you are supposed to approach for every question, right? Now I think you are very clear with the number of cubes, number of smaller cubes, how you are supposed to find them. You know the formula as well. Just implement it and get to your answer, right? So we will quickly finish the type 1 first. So the type 1 says that if a cube is painted on all of its surface, or on wall we can say, with single color. Now the color is same for all 6 faces, and then divided into various smaller cubes of equal size. Now we don't know that what is the size of smaller cube. Okay, the direction for the question, right? A cube is of 4 centimeter. Now they are talking about the bigger cube is painted black on all of its surface. So we know this, that the bigger size or the bigger cube is painted with black color with all of its surface and then divided into various smaller cubes with 1 centimeter. So what is the division? 4 upon 1, right? Comes out to be 4 division, right? I hope you are clear till here. We have calculated the first part. The smaller cubes are basically obtained are separated by from each other. Now you are supposed to calculate everything. The first part is the total number of cubes obtained will be. We know this. How many will be there? The number of cubes will be there are 4 on the first surface, 4 on the second surface, similarly on the third surface, multiplied by the, basically what they are doing, they are dividing the volume. So volume of the bigger cube will be this and the volume of the smaller cube will be this. So total of result that we'll get is 64. And remember this formula, volume of cube will be what? Sides cube. Side will be side of cube. I hope this part is clear. So here the sides cube is 4. So 4 cube will be 64. For smaller cube, what is the side? This volume will be, just a second. Yes, volume will be 1 cube, comes out to be 1 itself. Hence, the total number of cubes will be 64 cubes. We have calculated the first part of this question. Here, the number of division is 4 that we have already calculated in the previous slide. I hope till here you are clear with the question. Now we are supposed to calculate each and everything. The first thing is number of smaller cube with their 3 surfaces painted. As I have already told you during the briefing or during the conceptual part of this chapter, that for every cube there are 8 vertices. It means this number will be remain fixed. Hence the cube with 3 surfaces painted. So cube with what? 3 surface painted will always remain 8 for the cube. I hope this first part is clear. So again I will draw all 8 cubes for you. How you can do? First you can draw the hidden lines here itself, right? These are the hidden lines, right? Now I will mark all 8 cubes, all 8 vertices first. First 4 will be there on the top, rest 4 will be there on the bottom, right? I hope this part is clear. Total 8 vertices. I hope this part is clear. Now we'll move to the next part of this question, that is number 2. Number of smaller cubes with 2 surface painted. Just mark this. How many surface? 2 surface. We know the formula for that. That is n minus 2 multiplied by 12. We know the number of division, that is 4 minus 2 whole multiplied by 12 because of 12 edges. So the answer comes out to be 24, right? So the answer comes out to be 24 here itself, right? I hope you are clear with the second part of this question as well. Now what is going to be the third part? The cube with only 1 surface painted. So this is going to be the third part. So the number of smaller cubes with 1 surface painted is n minus 2 whole square multiplied by 6. 6 are number of faces. N is division. As soon as you are able to find these things, you know n is what? 4. 6 will remain 6. This comes out to be, again, this is basically a step is missing here. This comes out to be 2 square multiplied by 6. Then we'll have this step, that is 4 into 6 comes out to be 24. I hope as a class 10 student you are very well aware of basic mathematical operations, about your bracket, about your multiplication, division as well as subtraction, right? You are very well aware of BOD mass as well, right? right? We know this. What is this? Bracket of division, multiplication, addition and subtraction. I hope you are clear with the board mass, right? We have already discussed the concept of board mass in chapter name mathematical operations, right? So I hope till here you are able to find all three questions. Now we'll move to the next part. This is number of smaller cube with no surface painted. It means zero surface painted, right? This is what we are looking for. Formula for the same is n minus 2 whole cube. N is again 4 here, right? So the resultant will be 8. Resultant will be 8. I hope you are clear with this statement. I hope you are clear with this statement. I hope you are clear with the type 1. Now we are going to discuss type 2, in which the paint will differ from surface to surface. In type 1, what we did, we actually painted the complete cube with a single color, that is black. Here in type 2, we are going to discuss with a question, that is, if a cube is painted on all of its surface with different colors and then divided into various smaller cubes. This time the point to note is this: different colors. And again, we have a direction with us with which we are able to understand the division as well. So again, a cube, that is a bigger cube with side of 4 centimeter, point to note, is painted on the painted black on the pair of one opposite side. It means out of 6, 2 are painted with black. 2 are painted with black surface and blue on the pair of another opposite side. So 2 are painted with blue and 2 are painted with red, right? Total how many surface are there? 6, right? 2 are painted with black color, 2 are painted with blue color and 2 are painted with red color. I hope you are clear with these statements, and they are divided into smaller cubes with 1 centimeter height. So students, first we will do what? Division. What is a division? Represented by n, comes out to be 4 centimeter divided by 1 centimeter. What we will get? 4 division, right? It means n is equals to 4. I hope you are clear till here, right? I hope you are clear with the statement as well as the direction. Now start finding the question. So you have the diagram, this surface and the dotted surface at the back, this surface and at its back, and its back will be again a dotted surface, this and the dotted surface for the same. Okay, right? I hope you are understanding this particular figure as well. So basically what we are doing, if we are sitting in a room, let's say the top and bottom are painted black, both on the right and left side are pointed with red, and on your front and on your back will be painted with a blue color. I hope this part is clear, right? Now we know n is equals to 4 for our question. So the first statement is number of smaller cubes with 3 surface painted. So we very well know this. 8 vertices means 8 cubes will be there, in which 3 surfaces are painted. Right? Now, these smaller cubes will have all 3 surfaces painted with different colors. That is, this will be blue, black and red. What it will be? Blue, black and red. I hope this part is clear. If I have to represent, this is with blue, right? This is with black and this is with red. All 3 colors. I hope you are clear with this, right? All 3 colors. Okay, this is the first part. Second part is we have to find smaller cubes with 2 surfaces painted, which are total 24 in number. Now we are supposed to find out A, the number of cubes with 2 surfaces painted. 2 surfaces painted with a black and blue color, because total number is 24. Total how many colors are there? 3 colors. Simply divide them by 3, you will get 8. So 8 cubes will be there with how many colors? Black and blue. 8 cubes will be there with how many colors? Blue and red. And 8 cube will be there with black and red. I hope you are clear with this statement. All these things. Total of 24 will be there, out of which 8 are based on what? 8 are colored with black and blue, 8 are colored with blue and red, and the remaining 8 are colored with black and red. I hope this part is clear, right? Now, third part of this question is, how many smaller cubes are painted with one surface? It means they'll be painted with only one color at once, right? So, total of 24 is there, right? That is 4 on the each surface. How we get 4 on the each surface? It means if we talk about 2 surfaces, it means total of 8 cubes. They will be painted with black color, 8 will be painted with blue color, and the remaining 8 will be painted with red colors, because on one surface we have 4 cubes painted with only one surface. So it means 2 surfaces are painted with same color. Total of 8 cubes will be there. 8 smaller cubes will be there, right? Make sure how many smaller cubes we are talking about here, right? This is 24 total in number. 8 with black, 8 with blue, and 8 with red. I hope you are clear with this part as well, right? Now I am moving to the next part, and we can say the next type as well. Here the fourth part of this question is number of cubes. This will remain same, that is 64. This is the fourth part, and again the same, we have already calculated the surfaces on which they are painted. Either one of their surfaces painted, either 2 of their surfaces painted, either their 3 surfaces are painted. For 3, what we need to take care, that is all vertices. For 2, what we need to take care is number of edges. For third, what we need to take care is their what? Faces or the surfaces, right? Now we have third type. Till now in type 1, what we have discussed? Same color in 6 faces, right? Type 2, what we have discussed? Same colors in opposite faces. I hope this part is also clear and this part is also clear. Now type 3, in which we are going to have more different colors. So we are directly starting with the type 3. Here, if a cube is painted on its surface in such a way that one of the pair of opposite surface is left unpainted. Again, if a cube is painted on its surface in such a way that one of its pair is of opposite side remain unpainted or left unpainted. So direction is right. A cube with side of 4 cm. Just on the place of complete this statement, what you can write? 4 cm. This is the side of bigger cube. Is painted with red on the pair of one opposite surface. So on the one opposite surface it is red, on the other opposite surface it is green, right? And the one pair is unpainted. Now 64 divisions are there. 64 divisions are there with 64 smaller cubes, and one side is of 1 cm each. So again, what is given? Division is 4, and smaller cubes will be 64, right? I hope you are clear with this part. As one statement, one of the opposite sides are not painted, so we will find out again. So number of smaller cube with 3 surfaces painted is equals to 0, because each of the smaller cube at the corner is attached to the surface which is unpainted. If you painted, let's say, assume you are sitting in a room, if bottom and the top surfaces are not painted, it means all 8 vertices have at least one surface unpainted, right? It means it will be 0. I hope you are clear with this, right? If not, I'll repeat while I am ending this session as well, right? Now, second is number of smaller cubes with 2 surfaces painted is equals to the cube present at the corner plus the cube present at the 4 edges. Now this time why I am talking about 4 edges? Because rest 8 edges will be having only one side painted, not only 2, right? So here 8 edges plus 4 different edge, and at every edge how many will be there? 2 will be there, right? So 2 4s are 8, so total of 16 should be there, right? So this is it, 16 should be there. I hope you are clear with the statement as well, right? Okay, and okay, yes, this will be a plus here, right? Just mark this correction here, right? 8 plus n minus 2, that is 8 plus 4 minus 2 multiplied by 4 comes out to be 8 plus 8, right? Comes out to be 16. That is clearly written here as well, right? I hope you are clear with the statement number this as well. Now the third part. In third part, what we are discussing about the smaller cubes now. So you know very well that is one surface painted. Remember, one surface painted. So all the number of cubes present at the 8 edges plus number of cubes present at the 4 different surfaces. So for this n minus 2 multiplied by 8. For this n plus 2 whole square multiplied by 4. So it comes out to be, this is 4 minus 2 comes out to be 2 multiplied by 8. 4, here is minus 2 again, right? Not plus. Make this correction. 4 minus 2 is 2, 2 square is 4, 4 multiplied by 4. 16 plus 16 comes out to be 32. So 32 smaller squares will be there with at least one side painted. Now, the fourth part is, definitely we are talking about a cube in which no side is painted. I hope you are clear with this part as well, right? We are talking about cube in which no side is painted. So it means number of cubes on the 2 unpainted surface plus the number of cube present inside. Definitely the number of cubes, those who are on the unpainted side, as well as the number of cubes present inside it. So definitely they are what? 4 multiplied by 2, because 2 surfaces are there. It will be 8, and the cube inside will be, how this comes? This comes with this formula where n is equals to 4 that we have already calculated. So again it comes out to be 16. 16 cubes are there with no side painted. I hope you are clear with this statement. I hope you are clear with this type as well. Now we are moving to the fourth and the last type of this chapter. So in this type, what we are going to discuss, read it here only. If a cube is painted on its surface in such a way that one of the pair of the adjacent surface is left unpainted. One of the pair of adjacent surfaces left unpainted. It means a cube, now the direction part, a cube of side 4 cm is painted red. Okay, one side is painted red. A cube of side 4 cm is painted red on one pair of adjacent surface. Okay, one pair of adjacent surface, they are red. It means if these are the surface, this and this is painted, right? Okay, this surface is painted with this surface in which color? Red color. Okay, green is on the pair of another adjacent surface. Let's say green is present is here as well as this surface. The green is present in 2 different surfaces. Okay, Now, two of the adjacent surfaces are left unpainted. Let's say this and this is already covered, right? This and this is already covered. This and this will be remain unpainted. So we are talking about the adjacent surface. Centimeter given of smaller cube will be 1. So division will be 4. It means n is equals to 4 again. Now you can see here green, green. If I mark this thing, this is green, this is green, okay, and red. This is red. We have to draw the inner part as well, right? And this is red, okay, and the rest two are unpainted, right? Remember this, and remember this as well, right? Now the first part, the number of smaller cubes with 3 surface painted is equals to the 2. Reason is, rest 2 surfaces which are not painted will not touch these 2 corners. Rest they'll touch all 6 corners, right? Hence the 2 vertices will be the remaining vertices in which 3 smaller cubes, in which the smaller cube have 3 surfaces painted. I hope you are clear with this part, right? Second is, the number of smaller cubes with 2 surface painted is equals to the number of smaller cubes at 4 corners. Okay, 4 corners are what? Which are only having 2 surface painted, and the 5 as edges. So we know this, 4 corners will have 4 plus 5 edges. At one edge we have 2. So they will be 5 multiplied by 2 comes out to be 14. So 14 will be there. You can use the formula this as well, right? I hope there is no problem, right? Okay, 5 multiplied will be there, right? So you'll get here. Make this correction. Whenever I make any correction, make sure to note that correction down, right? Pen down that correction as soon as possible. Okay, now the third part of this question. Third part, we are supposed to find the smaller cube with 1 surface painted. You can read it here as well. Only 1 surface, right? Is equals to the number of smaller cubes at the 4 surfaces which are painted. It means we'll directly get 4 multiplied by 4, that is 16. 16 we get, okay, plus now number of smaller cubes at the 6 edges. At the 6 edges. So at every edge, how many we have? 2. So it will be 6 multiplied by 2 comes out to be 12 plus number of smaller cubes at 2 corners plus 2. How many will be there? 40. It will be 30 in total. You can see here as well. Formula used is this. Here it is missing, I think. Multiplied by 6 till here, right? And the last one is plus 2 for vertices. Right? I hope you are clear with the formula. I hope you are clear with the statement part as well. Now the fourth part and the final part of this question as well and this chapter as well. The number of smaller cubes with no surface painted is number of smaller cubes present from sides of the bigger cube. The number of cubes at the 2 surfaces and the number of cube at one edge. The first will be calculated with this, that is 8. N minus 2 square multiplied by 2 will be this. This is 2, not x. Make this correction here as well. So this is 4 into 8. 4 into 2 will be 8 and plus 2 will be there. Make this correction as well. Right. There are few corrections but total answer will be the same, that is 18. I hope you are clear with this part. Okay. So this is the end of this chapter as well. Okay. Total of 4 types are discussed in which what? Different colors are used to paint different surfaces or different walls. Okay, for every question or every type, what we are calculating smaller cubes with 3 face painted, right? With 2 face painted, with 1 face painted, okay, with 0 face painted. I hope you are clear with this part. So what we are doing, we are finding all these things again and again. Till here I have explained each and everything. I hope you didn't find any problem with this chapter now. Okay, as soon as you'll find a problem in which we are dealing with small cubes, in which we are dealing with bigger cubes, so first thing you need to find out the division. That will be marked with the help of n, right? First will be division marked with n. Second will be type. Either it is first, second, third or fourth. Which type that particular square or cube belongs to. Third is use formula. Right. Fourth is mark your answers. Okay. These are the basic steps that you have to follow throughout this chapter. Right. And with this, from my end, I have completed this chapter. Anybody is facing any problem can watch this video again. Make short notes of it of all four types. Okay. And for better practice, because till here we have discussed four types and four questions, so you can go and like work with 10 to 15 more questions so that you'll gain good confidence and hold on this chapter. For that, what you can do, you can visit to the website and do the practice set of this same chapter with the name cubes test. With the name cubes test, the practice set will be there with the name of cubes test. Okay students, so thank you for watching this video. Bye bye.